In section 7.1, our goal is going to be to simplify rational expressions. That's kind of a fancy word, or a fancy expression. But here's what it means. You're going to have a polynomial divided by another polynomial, and you just want to simplify that a little bit. So let's see how that's going to look. Now, the one thing that I want to remind you of is something that we cannot do while we're working with fractions, and that is divide by 0. You cannot divide by 0. In problem number 24, they give you an expression 5x over x plus 5. The instructions are to find all the real numbers for which the rational expression is undefined. Well, it's going to be undefined if the denominator is 0. What value of x would make the denominator 0? Not 5. Negative 5. Yeah. So x can't equal negative 5. And that's it. In problem 32, you've got x cubed minus x squared over 15. Do we have any problems with the denominator here? Can the denominator equal 0? No. This is defined for all real numbers. Not quite the case with problem number 34. 2x minus 15 over x squared minus 49. What value of x, or what values, are going to make the denominator 0? That's half the answer. X can't equal 7. Well, here's what you should do. Set this equal to 0 and solve. So this will factor. How's x squared minus 49 going to factor? Thank you. X minus 7 and x plus 7. Ruben, can you read off the two solutions from this? Good. So really you got plus or minus 7 here. There's two solutions. Positive 7 and negative 7. Can't have x equal either of those. Nice. The main thrust of our work, though, is going to be to simplify fractions. For example, if you had something like 12 over 18, that's not in lowest terms, right? Because you can divide out a 6 and get 2 over 3. The same thing is going to happen when we work with certain rational expressions, like problem number 46. Now, back in section 6.7, I told you something there that's going to be true here. Factor first. You need to factor these things first before you start doing any kind of cancellation. And that's very, very true in this section. Problem number 46 is 2x minus 14 over x minus 7. Boy, it's really tempting to want to cancel out that x and cancel into that 14 with the 7. You can't. You can't because these terms are kind of stuck together. X minus 7 is one whole term. I can't cancel into that parenthesis. Likewise, I can't cancel into this parenthesis. But what I can do, in the numerator, I can factor out the GCF. 2 times what? X minus 7. Now, I can't cancel into a parenthesis, but I can cancel the whole parenthesis. What am I left with? 2. 2 over 1, or better yet, just 2. But it relies on you factoring these things first. You cannot, absolutely cannot cancel right here. Let's try another one similar to the last one. Problem number 50. X squared minus 10x plus 21 over x squared minus 3x. Okay. How can I factor these things? And this is where you have to be really good with factoring these things. Yes, sir. Yeah, you're gonna factor them separately first. So in the numerator, x and x. Karanja, can you help me out? Two numbers that multiply to 21 and add to negative 10. Thank you. Negative 7 and negative 3. Good. Ted, can you see anything to do in the denominator? Good. Factor out an x, right? X is your GCF. Always, always, always look for the GCF. Are we done? No? Yeah, now comes the fun part, right? Now you take out your special Zorro pen. Ole. And cancel those things out. All you're left with is x minus 7. Yeah, over x. Thank you. So really, most of the work in this section is factorization. Let's try problem number 94. Kind of a big jump here. 3y minus 5, no, 3y minus 2 to the 5th over 9y squared minus 12y plus 4. Notice something about these outside numbers. What's interesting or noteworthy about those outside numbers? They're both perfect squares. What do you square to get this one? 3y. And you square a 2 to get this one. Now check to see if the middle term is 2 times 3y times this 2. Does it fit that pattern? Yeah, 2 times 2 is 4 times 3 is 12. So this is really 3y minus 2 squared. Good. 5 minus 2 leaves you with 3 of these. 3y minus 2 cubed. And that's it. You're done with 94. Now I did number 94 so that I can give you a chance to look at problem number 54. Problem 54 looks like this. 9y squared minus 12y plus 4 over 3y minus 2 cubed. Okay. The numerator you already know, right? We did that in problem number 94. It's 3y minus 2 squared over 3y minus 2 to the third power. What's left after I do any cancellation? One over 3y minus 2. Now you can write parentheses to the first power like this. That's fine. You don't have to. If it's to the first power, you can just write it as 3y minus 2. Either one of them is fine. What I suggest in doing this is you subtract the exponents, the smaller from the larger. 3 minus 2 is 1. Leave it wherever the larger one was. Some more that are a little bit more typical of the work you're going to do. Let's do another kind of little phase here. Factor out -1. So problem number 60 is 18 minus d over d minus 18. I'm going to show you the long way, and then I'll show you kind of a shortcut that you can and should use. It looks really tempting. You got an 18 and 18 here, you got a d and a d here. Boy, it just looks like, gosh, you should be able to cancel it all out. It's close to that, but not perfect. If I factor out a -1 here in the numerator, factoring out a -1 changes the signs on both of those terms. So I get a -18 plus d. That's equivalent to what I have here. You can check it by distributing here. If I distribute, I get a positive 18 and a minus d. Since addition is commutative, that is, you can add things in any order, I'm going to rewrite it like this. Negative of d plus -18, or better yet, d minus 18. Is there anything I can do now? These terms cancel completely. Something divided by itself is 1. But what's the final answer for us here? -1. In general, when you have a minus b over b minus a, you're going to get -1. That's something you should expect to use. I promise you, you will have stuff like that on your exam. Let me give you a little help in practicing and seeing this. Thomas?
Well, at the beginning, it was 18 minus d over d minus 18.
Right.
And then you put in the parentheses minus 18 plus d.
But notice what's outside the parentheses. I got a negative outside the parentheses. So if you distribute that, this, negative times a negative is positive. Negative times a positive is negative. So these two numerators are equivalent.
Yeah, but what I mean, it was not positive in the first one.
I did change the signs. I changed the signs so that I could make these two terms the same. Now in changing the signs, I had to factor out a negative, which I left here. That negative stayed throughout the problem. It's here, it's here, it's here. That negative never left. So what I'm showing you is a shortcut for...
Yeah, but what I'm asking, in the second step, how did it change plus and e was minus? It was not plus.
That's because I factored out a negative. When you factor out a negative, it changes the sign on both of those terms. We saw that in our previous section. I think there was a place where we factored out a negative right here. I factored out a -2 from both of these. Now, if you notice right here, you've got a -4x and a +2. If I factor out a -2, that changes both of the signs. I've got a positive here and a negative here. So when you factor out a negative, it changes both signs, or all the signs, really. let me give you a numerical example just to show you that this works in general. So let's do, say, 17 minus 38 over 38 minus 17. In the numerator, I'll get negative 21. In the denominator, I get positive 21. Overall, you get negative 1, right? When you simplify it. And what I'm saying here is that anytime you see something like this, you can cancel and get yourself a negative 1. It doesn't have to be just numbers. It can be expressions. You do not have to show me this work. I did it for you once. You don't have to show me this work. Yes, sir.
No, also been okay if you just moved 17, like you canceled out both 17s but left the bottom one, and then canceled out both 38s and left the top one or something.
Boy, if you cancel the 17s here, I'll be rather uncomfortable. These things, kind of like we said earlier, even though I've got numbers here, they're married. You cannot cancel into that. So if you cancel out the 17s and then cancel out the 38s or not, but even canceling out the 17s, yeah, you're risking a frowny face or worse. You can't. Mathematically, you just can't cancel into those. So maybe do yourself a favor and put parentheses around those expressions right away so that you realize that they're married. And if you break up that marriage, you're going to write homewrecker all over your test. All right? Can't do that. All right. Let me give you a couple examples with this. We'll start with problem number 66. You guys have some good questions this morning. I appreciate them. 36 minus 6h over h squared minus 36. Well, I'll tell you what. Heeding my own advice, I'll put parentheses around that one and parentheses around that one. I cannot cancel the 36's, nor can I cancel the h's. But I can factor things out. Let's start with the denominator. I'm hoping you recognize that one. Big E. What's the denominator going to factor as? And minus 6. You said it. You just got a little tongue-tied. It's all right. I appreciate your help this morning. How about the numerator? Sabrina, anything that you see we can do there? All right. I'll factor out a 6. What's that leave behind? 6 minus h. Now notice something about these two here. And this is going to be kind of a personal preference here, but h minus 6 and 6 minus h, this is exactly what we mentioned up here. This whole thing cancels and can be replaced by a negative 1. I would suggest you put the negative in the numerator, but really it doesn't matter. It's just more convenient to do it in the numerator. So that leaves me with negative 1 times 6 is negative 6 over h plus 6. And that's it. We're done. We cannot cancel any further. Keep in mind that just like earlier, those terms are stuck in parentheses. You cannot cancel the 6 into that 6. That's as far as you can go here. I'm going to leave a little space here. I'll go back and show you a little different approach on that for those of you who aren't terribly comfortable with our cancellation. Let's try problem number 70. (81) minus y squared over y squared plus 10y plus 9. Again, I'm going to start by putting parentheses around these. Remind myself that I can't cancel the 9 into the 81 or cancel the y squareds, but I can factor these. Victoria, how about the numerator? How's that one going to factor, please? Nine plus y and 9 minus y. Good. Did anyone get the denominator? How can I factor those two terms? Y and y, plus and plus. Two numbers that multiply to 9 and add to 10. 9 and 1. Yay. Ooh. This one's a little different. Y plus 9 and 9 plus y. These terms are essentially the same. There's no minus in here that we have to worry about canceling. So that's just a 1. We don't have to worry about that one at all. Our overall answer is 9 minus y over y plus 1. Why was this one different than the last one?
It's because 9 plus y and y plus 9, it doesn't matter the order, it's because it's adding.
Exactly. And then when you're subtracting, the order makes a difference. When you're adding, the order doesn't make a difference. So, well done. Let me give you more of a standard type of problem from this section. This is kind of the bread and butter problem that you would definitely want to make sure you'd be able to solve. Problem 74. X squared plus x minus 6 over x squared minus x minus 2. As before, the thing you're going to do with these things is factor first. So, factor first. Let's see what we can do with each of these. Ted, suggestions for the numerator. Two numbers that multiply to negative 6 and add to 1. One has to be positive, one has to be negative. 3 and 2. The larger one has to have that sign. How about the denominator? George? Two numbers that multiply to negative 2, add to negative 1. Good. Negative 2 and positive 1. And as with a lot of these things, you get some cancellation. X plus 3 over x plus 1. Can I go any further than that? No, that's it. These things are understood to be in parentheses. You can't cancel into those parentheses. Let's stop it here. For homework, try 23 through 33, 39 through 83, and 93.